The journey begins. This continuous convoy of raw material leaves the natural source, traversing vast distances.
Sorted and cleaned, the uniform raw material is now ready. These logs are directed toward the chipper, the machine that will perform the first major reduction.
The washed pulp is stored. These high-density towers hold thousands of cubic meters of pulp slurry, providing a
centrifugal cleaning. The pulp undergoes high G-force cleaning in these hydrocyclones, removing even microscopic denser impurities.
The size press applies starch. This coating seeps into the sheet, sealing the surface. It reduces ink absorption and improves sheet stacking and jogging. Contactless conveyors prevent marking. Automated systems.
Our journey begins not in a factory, but here at the primary source. This vast
These trees, primarily softwoods like pine and fir, are the ideal raw material. Their long fibers will create the first transformation. Harvesting begins, selecting mature trees to maintain the forest's sustainability.
The raw material is immediately mobilized. Industrial-scale forestry equipment collects and consolidates the harvested parsley. The raw timber is amassed. This mountainous pile represents the first aggregation point, where individual trees.
The journey begins. This continuous convoy of raw material leaves the natural source, traversing vast distances.
The raw timber enters the mill's circulatory system. This powerful flume uses water to efficiently transport
the first violent transformation. In this colossal drum, the logs are tumbled violently against each other and the machine's walls.
Sorted and cleaned, the uniform raw material is now ready. These logs are directed toward the chipper, the machine that will perform the first major reduction.
The reduction begins. In the heart of the chipping plant, gigantic rotary discs with fixed blades reduce in.
The raw feedstock is stored. These colossal silos act as a buffer, holding thousands of tons of wood chips.
The journey into the chemical heart of the mill. This continuous river of chips is precisely metered and fed into the next stage.
The cooking chemicals are introduced. This white liquor is pumped at high pressure and temperature into the digester, where it will permeate. Inside the digester, a continuous reaction takes place. Under high pressure and temperatures exceeding 107 Celsius, the reaction is halted. The cooked mixture, now called brown stock, is violently ejected into the blow tank.
The first cleaning stage. These industrial vibratory screens remove any large, uncooked fragments of wood or debris.
The chemical recovery begins. These colossal drum washers rinse the pulp clean of the spent cooking chemicals.
The washed pulp is stored. These high-density towers hold thousands of cubic meters of pulp slurry, providing a
Fine screening. Using precision slotted screens, the process removes fiber bundles and smaller debris.
The bleaching process. In this multi-stage oxygen delignification and chlorine dioxide tower, any remaining.
The bleached pulp is now directed. Based on the final product specifications, the pulp stream can be split, blended, or sent.
The final recipe is blended here. Different pulps and additives merge.
Critical additives are injected. Fillers like clay improve smoothness and opacity. Retention aids help bind everything. Dyes set the precise shade. Critical additives are injected. Fillers like clay improve smoothness and opacity. Retention aids help bind everything. Dyes set the precise shade.
The stock is now ready. This calm, pressurized flow moves toward the heart of the operation, the paper machine headbox.
The stock hits the wire. It jets from the headbox slice at the exact same speed as the moving mesh. This synchronization is the first act of sheet formation.
The web is formed. Water immediately begins draining through the moving wire by gravity. A mat of interlocking cells.
Initial drainage. Gravity and centrifugal force from these rolls remove vast quantities of water, consolidating the fragile fiber material.
Vacuum dewatering begins. These flat boxes apply suction, pulling more water out and compacting.
Centrifugal cleaning. The pulp undergoes high G-force cleaning in these hydrocyclones, removing even microscopic denser impurities.
The dandy roll imparts a finish. It can add a watermark or a specific surface pattern.
The first press nip. Enormous pressure from these steel rollers mechanically forces water out. This massively increases sheet density.
Progressive pressing. Multiple nips, each with different roll surfaces, continue to remove water and compact the sheet. Smoothness improves with each pass.
The dryers begin. The sheet enters a battery of steam-heated cylinders. Here, thermal energy will evaporate. Thermal drying. The sheet travels over dozens of heated cylinders. As it moves, remaining moisture flashes into steam.
Moisture flashes to steam. This intimate view shows the final water being driven off. The sheet is now over 95% dry.
The sheet is dry. Sensors immediately scan its weight and moisture profile across the full width. This data is fed back to the machine controls for real-time adjustment.
The size press applies starch. This coating seeps into the sheet, sealing the surface. It reduces ink absorption and improves.
Excess starch is recirculated. The sheet now carries a precise, controlled weight of starch coating on each side. It must be dried again.
The coating is dried and cured. Heat sets the starch, bonding it to the paper fibers. This creates a hard, smooth...
The calendar stack. Here, under immense pressure and heat, the sheet is smoothed and polished. This controls the final... This is the essence of paper, the cellulose fiber. Every step of the industrial process is designed to...
Centralized control. From rooms like this, every parameter of the massive, continuous process is monitored.
Continuous quality assurance. Automated labs run 24/7 tests on the process stream. This data feeds back to the control room, allowing for instantaneous corrections. Nothing is wasted. Off-spec paper and edge trimmings are fed back into the system at the pulper. This broke is reclaimed.
Energy self-sufficiency. The bark stripped earlier is used as biofuel. This on-site power plant generates...
Machine maintenance is constant. Critical rolls are regularly reground to maintain perfect smoothness and geometry.
Provide human oversight. In this automated landscape, skilled technicians monitor, listen, and make fine adjustments.
The master roll is unwound. It feeds the paper at high speed into the slitter rewinder. This machine will cut the wide web.
Slitting. Rotary razor blades cut the full-width web into narrower strips. The cuts are clean and dust-free, maintaining the paper's perfect edge quality.
The strips are separated. Each slit strip is independently guided and tensioned. This ensures every final customer roll is wound with consistent tightness and alignment.
Sheet stacking and jogging. Contactless conveyors prevent marking. Automated systems.
The new roll is started. Each strip is automatically attached to a fresh core. The rewinder then builds multiple
rolls are wound simultaneously. This high-speed rewinder can produce dozens of finished rolls from a single parent reel, maximizing efficiency and throughput.
Finished rolls are discharged. They are automatically transferred to pallets for transport.
Every roll is weighed. This fine check, trim, and seal the paper on the roll, ensuring it meets the customer's order.
Labeling and identification. Each roll receives a unique barcode label. This tracks it through shipping and to the customer's press room, ensuring full traceability.
The rolls enter automated storage. This high-density warehouse holds thousands of finished rolls. Inventory management.
Protective wrapping. Each roll is sealed in tough, water-resistant paper. This guards against dust, moisture, and damage during transit. The roll is secured to its pallet. Steel strapping ensures the multi-ton roll cannot shift during transport. It is
Staged for shipping. Finished roll consolidated in the loading bay, grouped by destination and order.
The container is loaded. Each roll is meticulously positioned to maximize space and weight distribution. The mill never sleeps. This continuous industrial process transforms raw timber.
Distribution begins. A continuous convoy of trucks departs, linking the industrial complex to printers, publishers, and converters.
The ultimate symbol of industrial continuity, the flying splice. The paper machine operates for weeks.
Sheeting. For customers who require cut sheets, the continuous roll is transformed. High-speed rotary cutters slice the web.
The paper is wound. At the reel-up, the continuous sheet is wound into a giant master roll, or parent reel.
The master roll is removed. Weighing several tons, it is transferred by overhead crane to the next station.
In the finishing hall, the master roll begins its final transformation. It will be unwound and slipped.
The finished product awaits. In this controlled environment, paper is stored, preserving its precise moisture.
Order picking. Guided by warehouse management systems, forklift operators retrieve specific rolls or pallets.
The paper is printed. Before becoming a notebook, the large rolls are printed with lines, grids, or textbook.
Printed sheets are cut. The web is transformed into stacks of identically sized pages. The future leaves of a notebook. Perfect binding. For softcover notebooks, this adhesive binding method creates a strong, flexible spine. The adhesive sets saddle stitching. For notepads and smaller booklets, heavy-duty industrial staplers bind the pages at the spine. This is a fast, durable binding method for everyday use.
Palletizing. Robotic arms built with precision and strength impossible manually.
Face trimming. The bound but uneven edges are trimmed on 3 sides in one powerful stroke. This gives the notebook its final, precise dimension.
Automatic packaging. Each notebook is sleeved or blister packed for retail display. This protects the product and allows for immediate barcode scanning at the point of sale.
Secondary packaging. Individual notebooks are grouped into retail-ready cartons. This prepares them for efficient shelf stocking and provides an additional layer of protection.
Bulk shipping preparation. Cartons are palletized and unitized, just like the raw paper rolls were.
The journey concludes. From raw timber to printed, bound, and packaged notebook, the cycle is complete.
The notebook reaches the distribution hub. Here, in vast warehouses, countless manufacturers are sorted.
Store-bound. Cartons are broken down from pallets and loaded onto delivery trucks destined for specific retail locations. This is the last leg of the supply chain.
At the retail store, the carton is opened in the stockroom. The notebooks, their industrial journey complete, are now mere steps away from the consumer.
The product finds its place. Arranged on the shelf, the notebook is now a commodity waiting to be chosen.